I'm going to show us the easiest way to solve Kirchhoff's law without even having to write anything. Now, because I'm going to be explaining, it's going to take me some time to do it. Now, the first thing we should know is that this is a 2-loop circuit. So this is loop 1, this is loop 2. Now, what's the next thing you do? You make every possible combination of this that you can have. It starts with 1, 1. As if you are arranging the element of a matrix. You have 1, 2. You have 2, 1. You do 2, 2. So 1, 1 means the resistance in the first loop alone. 1, 2 means the resistance between the first and second loop, which there is nothing. What is 2, 1? Between the second and first, then inside the second alone. So that's how you do. You first stay in the first loop. Look at all the resistors there. From there, you move to every other loop. What do? You take the second loop. Consider every loop before it, before considering it. Then consider, after considering it, then you move to the next loop. So I'm going to stay in the first loop. Consider every loop before it. Is there any loop before the first loop? No. So it is only the first one. So I consider the first one. Then consider between the first and the next. If there is still another one, I will consider between the first and that one also. But there is no other one. So I just need to stay inside the first. Consider the first and the next. Consider the first alone, then consider the first and the next. Then stay inside the next one. Consider the next one and the first one before considering the next one, because I have to do for every previous one before I do that particular one, right? Then the last part will now be the voltages. These are the resistances. Then we have what? The voltage. So the total voltage in that loop. You can do that by either going clockwise, or you go the same way in both loops. So if you go clockwise here, you have to go clockwise here too, so that this rule will work. Now, another thing you must notice for this rule is that before it will only tell you the current in one part, in one branch, not in the middle branches. As you can see that this branch is between loop 1 and loop 2. So I won't get the current here. I will only get the current in this part and the current in this part. Then I can get the current in this part, right? So let's see it in action. So this is 2 loops. I pick simultaneous equation of 2 unknowns. That's the first one. And for this, I will stay in the first loop. Consider all the resistors in the first loop. So let me show you that. This is everything in the first loop. So everything my line touches, I must consider it if it's resistance. So how many resistors are my red line touching? Only one, which is the 7 ohm. So I enter 7. Now I will move from first to second. Is there any resistor in between? No. So in my calculator, I'll put 0. Now, what is the voltage in the first loop? Total voltage going clockwise. So this is, if I go clockwise, I move from positive to negative, that's -6. If I go clockwise, I move from up to down, that's -4. So I open my calculator, I say -6 -4. I'm done with the first loop. Now I will stay in the second loop. I will stay in the second loop. Move from second to first. Is there any resistance? No. So that will be 0. Then in the second, I will now stay in the second loop. Is there any resistance in the second loop? No. Sorry, is there any resistance in the second loop alone? Yes, it is this 5, right? So I open my calculator, enter 5. Then I will go around this second loop. This is what? A rise of 8. This is what? A rise of 4. So I say +8 +4 +8 +4. So 12. So this gives me -10/7 as the current in the first part. Now you discover that I was going clockwise, right? So for me to get negative answer means it is anti-clockwise. It's actually this way. Exactly the way they pointed the arrow. So this is 10 over 7, right? What's the second current? 12 over 5. So I went clockwise, right? So for me to get a positive answer, that means it's still clockwise, 12 over 5. So look at this current. This is what 10 over 7, this is what 12 over 5. They will come here and meet and produce this current, right? So this current will be what? 10 over 7 plus 12 over 5. So let's do that. 10 over 7 plus 12 over 5. That gives me what? 3.83. So this current is 3.83 amperes. So let's check their answers. Look at that. 3.8 amperes, 12 over 5 amperes, 10 over 7 amperes. So we are what? We are very correct. Let's try another one so that you become more familiar with how we are doing this. Now, if this switch is closed, that's when I can use Kirchhoff's law. If it's not closed, I won't use Kirchhoff's law. I'll just do it normally. So I will do for when the switch is closed. So when this switch is closed, this is loop 1, this is loop 2. So I will stay in loop 1, mode 5, 1. Stay in loop 1, all the resistors in loop 1. All the resistors in loop 1, we have this 7 ohm and this 4 ohm. All of them, they are connected to this loop 1, right? So I will say 7 plus 4. And between 1 and 2, that's what? This 4. Now, if I want to enter any resistor in between, I will put a negative sign before I enter it. Then I will enter the voltage in the first loop, going clockwise. This is what? A rise of 12, because we are moving from negative to positive. A rise of 12. Is there any other voltage? No, no other voltage. So just a rise of 12. Now, I will go to loop 2. Now I have to do between 2 and 1 before I do 2 and 2. So between 2 and 1 is also this 4 again. So I will say minus 4. Now stay in the second loop. What are the resistors that we have in that everywhere my green line is touching? 4 and 8. So I will say 4 plus 8. 4 plus 8. Then go clockwise and take the what? The voltage. So we are going clockwise like this. Is what? Minus 9, right? So there is no other voltage in this part. So I will just come here, put minus 9. And the first current is what? 27 over 29. So that's the current in this part. Now I went clockwise. So clockwise is correct. 27 over 29. Then the second one is what? Minus 51 over 116. That's what? Minus 0.44. So this will be pointing this way, 0.44. I assume it was pointing this way because I was going clockwise. Now it is anti-clockwise. So when the two of them meet at this point, they will join and produce this current, right? So this current will simply be what? 27 over 29 plus 0.44. So let's do that. 27 over 29 plus 0.44. That was 1.37. So this current is what? 1.37. I3 is 1.37. So I1 is what? 27 over 29. 27 divided by 29. That's what? 0.93. 0.93. I2 0.44. I3 is what? 1.37. Let's check. Look at that. 0.44. 0.93. What is the last one? 1.37. We are very correct. Very correct. Let's look for another one. So there's an unknown resistor here, so we can use Kirchhoff. We can use calculator. Use calculator for when everything is complete. Wow, that's all. I can still use my calculator to do this too. Let me use my calculator for this. So everything here is just 2 loops. There are not 3 loops. If it's 3 loops, it will still work the same way. Loop 1, loop 2. Now go clockwise, go clockwise. So take your calculator, mode 5, 1. Now inside the first, what is total resistance in the first loop? That is what? 0.3 plus, that's an internal resistance, but I will still consider it, plus 0.2. Between the first and second loop, I have what? Minus 0.2, because that 0.2 is in between. Then if I go clockwise in the first loop, like this, I will have what? A drop of 6. Then by the time I get here, I go like this. I will have a rise of 5. A drop of 6, a rise of 5. Between the second, now go to the second loop. Between the second and first, I have what? I'm considering resistance, minus 0.2. Minus 0.2. Inside the second loop alone, I have what? 0.96 and what? And 0.2. Please, I have to do everything that is connected to the second loop. Anything my green line is touching this 0.2, it's touching this 0.96, right? So I will say 0.2 plus 0.96. Now go clockwise. Now by the time I get here, I'm going this way, right? A drop was what? 5. That's the only voltage source that we're having. A drop of 5. So I get what? Minus 4 amperes. Now I took the current to be going this way. So that means it's actually going this way. And it's going to be 4 amperes. Then for the second one, I get what? Minus 5 amperes. So the current here is also going this way, and it is what? 5 amperes. So what about the shared parts? So what will I do? I know that when this 5 ampere will enter here, 4 ampere comes out. So that means the remaining 1 ampere will come here. 1 ampere. So those are the values of the current. Let's check. This is 29.72. 29.72. Oh. Okay. Here what? 5 amperes, which is exactly what you got. 5 amperes. That's if it is the current 4.8 volts, 4.8 volts. 29.72. The current in the 0.96, yes, that's 5 amperes. Right? This current in the 0.96, that's 5 amperes. So don't have problem with that. So do this exactly the same way. This is also 2 loops. Let me find the one that has 3 loops. There isn't any. Wow. You don't have any with 3 loops. You don't have any 3 loops. So what should we do?